Hello, I'm Marcus. I chose to rework problem 1 from test 1. This was the coding function of a pelican diving at a 20-degree angle into the water. I'm going to go over my major mistakes and how I fixed them. So we were given that the drag is a constant times the speed cubed. The pelican's mass is 15 kilograms. We know that time starts at 0 and delta time is 0.001. It is asking us to be able to write a function in the while loop that will update the position and the velocity. So to do this, we go into the while loop. We get the force of the earth, which we know is just acting in the negative y direction, so it's 0 negative gravity times the pelican's mass. Then what we do, we find a unit vector of the velocity. So I take the norm, which is a function in VPython that takes a vector and gives us our unit vector. So that gives us the direction of the velocity. And since we know that drag is negative to this, in F air we're going to do a negative b times unit vec times the speed cubed. So F net is these two forces added together, so we get F net equals F air plus F earth. Now that we have F net, we can use Newton's second law and update pelican dot velocity. The major mistake I made here and why I highlighted it is that I did not use pelican dot velocity as the final answer. I used something else. But this is wrong because it doesn't constantly update the pelican dot vel. If I name it something else, it will name that variable, but the pelican dot velocity and pelican dot position will never change. So we actually won't ever update the pelican dot vel and pelican dot pos. So with these major things taken care of and dealt with, this code will work perfectly if put into VPython. Since down here we have the t gets updated constantly, and while t is less than 1, it'll keep running. At the end, we're going to print the t and the pelican's position. I hope this helps you further understand question 1.